In a similar way, we could stabilize the operation point by canceling this AC signal and maybe trying to measure, if I apply some AC signal here, I can try to measure the operation point of the R out. Let's draw that. So R out by small signal, if we draw the graph for R out, so we have ID over VDS, and we know that the graph is not really flat, so we're looking at 1 over R out right here. So if I can operate at a certain operation point right here, and then just move around that point, it's very similar. I can measure R out in a similar way, and then I could just use the equation of ID over VDS when VGS is simply 0. So all this, of course, -1. So that makes things a little more easier. So the trick is, how do I do this in simulation? So I'm going to show you that now. I have my and let's say even more so. Let's say this, we have a very complex box that has, let's say, 100 transistors in here. We might have a few stages of amplifiers. We might have some gain boosting. We might have some sub-threshold operation, and that would be very hard to evaluate based on equations and solving for KCL and KVL and doing a small signal, because that we might never finish. So maybe we can just measure the parameters using a small simulation, and that will help us evaluate our circuit better. So we have prepared a small test bench. So I have a differential amplifier here. It's a very simple single-ended differential amplifier. We have a reference right here, IREF of 50 microamps. And I would like to measure the GM and R out of this circuit. So if I would have to go and evaluate it by small signal, we know that that usually the GM of this circuit should be very closely the GM of one of these transistors, either XA diff IP, N diff IP, or XA N diff IN. Usually that would be the GM of the circuit, at least without too much parasitics. And the R out of the circuit, meaning if I look from the OP terminal, I would expect to have some parallel resistance of this transistor over here with this transistor over here. So the question is, let's say I did not know that and I would want to measure that. Is that even possible? So if I go to my test bench right here, I've prepared a small test bench which can measure these parameters. So this is the amplifier, and we have the inputs IP and IN. We have the reference, and we have our supply and our VSS and the output. So what do I do in order to measure this? So on the input side, I have a DC voltage that is supposed to put the amplifier in the correct operation point. So this is equivalent to putting the VGS that we want to put it into our operation point of the current that we want. So I've applied some common mode voltage here. It's going to be about 700 millivolts. And on top of that, I'm going to apply an AC signal, which will show the differences on the graph of the I versus V in. So that will help us measure the GM of the circuit. So we're going to be looking at I out over V in around a certain point. So if we just go ahead and write that, and then we will have that GM in small signal, or an AC simulation, is going to be I out over V in